coordinate of that point is this 4 KSI. Do you see that? So, x coordinate of the point on the circle that corresponds to that red vertical face is 4. Now, Helen, tell me, would that be positive 4 or a negative 4? You're absolutely right. It's a positive 4. Why? Because, look at it. The stress that we show is pulling away from the face. You see the arrowhead? So, the x-coordinate is plus 4. What do you guys think the y-coordinate of the point would be? Well, the y-coordinate of the point would be equal to 6 KSI. Where did I get that? That's the shear stress. All right? So, let me see if I can write 6. Please accept that as a 6. But the question becomes, is that a plus or a minus? Positive 6 or a negative 6? Well, let's go back to 2 or 3 slides before. This is how you decide. All right? Shear plotted down or negative. If on this page, look at this. That's the face we were looking at. If on that face, the shear stress is acting upward, like it is for our problem, is that plus or minus? It says plotted down below the x-axis, so it's minus. All right? Let me tell you another way of looking at it, a quicker way. Look at each one of these separately. All right? So just look at the shear stress acting on one face. That shear stress acting on the face, does that create a clockwise or counterclockwise rotation about the center of the block? Guys, to keep things in perspective, I'm trying to decide whether this shear stress, which would be the y coordinate of the point on the circle, is it plus or minus? This is what you do. Just take a look at that shear stress, the way it's acting, it this way upward. Would that cause the block to rotate clockwise or counterclockwise about the center of the block? Well, think about it. It would be in this direction. So that is counterclockwise. If it turns it or rotates it counterclockwise, then it's negative. All right? If it were acting downward, that would cause clockwise, it would be positive. So this is the quickest way that I can tell you how to decide that. Therefore, coming back to this problem, the coordinate would be plus 4 and minus 6. Does everybody agree? All right. Now, if you agree with that, before I go to the next slide, tell me something. Could you please tell me what are the coordinates associated with this plane right here, the horizontal plane? Well, the point would have an x-coordinate and a y-coordinate. The x-coordinate would always be the value of the normal stress. In this case, it's an 8. So it's an 8. Now tell me, would it be positive or negative? I'll wait for you. Tell me positive or negative. Negative. Steven says negative. Why? Because it's a compression. It is pushing towards the face. All right? What about the y coordinate of that point? The y coordinate of the point, that's the shear stress. Would that cause the block to go clockwise or counterclockwise? If you said clockwise, you're correct, and would be plus 6. Does everybody follow so far? All right, now let's put this together. Remember these coordinates? This is what I'm going to do next. I'm on slide 38. Just draw the x-axis. The x-axis is going to be the sigma. Stresses are plotted on the horizontal line. Tau, shear stress, plotted on the y-axis. like that. Then the next thing is the points. You have to identify the points. 4 minus 6, I showed you how I created that. That's that point is that face. And this face here is this point here. So far, so good. So we just identify the coordinates, plot them on this XY coordinates. Now, what do we do next? Connect those 2 points. Point X and Y that we created. Just connect them. Look, guys, if each of those points is a point on the circle, then this line that we have drawn from X to Y, don't you agree? That is a diameter. That's one diameter of the circle. You should agree because it is correct. So what I want you to do next is just draw that line. Some people have asked me, when I cover this, they say, well, should we take tools that we can draw a perfect circle and measure? Well, no, you don't need to do that. Just be careful about approximately measuring these close to what they're supposed to be. All right. So when you draw this line, that's the a diameter of the circle. So one thing we identify is this: we need to identify the coordinate of that line, that point, the intersection of that diameter and the x-axis. And if you look at the numbers, that comes out to be -2. Please, I want you to go over the numbers. When I say the numbers, look at the 4 and the -6, the 4 here and the -8. The distance between those 2 points. Those are x-coordinates, right? So between 4 and -8, you divide it by 2, you end up at a point that has a coordinate of -2. What do we do next? Well, next thing that you do, you create the circle. And when you draw it, it does not have to be a perfect circle. Just draw the circle, approximately. All right? Now, remember, guys, what they asked us to do. They said, please find the principal stresses. Find the principal stresses. And I will show you. If any point on the circle represents a plane on this square, then as we rotate, remember, we're going to rotate different planes and see which one of these planes contains the principal stress or the maximum stress. So each of those planes that I'm rotating are presented by a point on the circle. So guys, critical thinking here. I want you to pay attention and tell me on the circle, what point on the circle do you suspect the maximum and the minimum stress occur? In other words, what point or points on the circle will give you the highest value of X? Matthew says top and bottom. No, it's not top and bottom. Caleb says on the axis, crossing axis. Jeremy says, guys, okay, here is the answer. This one. You see this? Matthew, look at it. This point would be the point on the circle that would give you either the highest or the lowest X value, which would be the stress. Mary, do you agree with that? And the point on the left-hand side where the circle crosses the x-axis. Guys, all you have to do, now the problem, no, these are not absolute values. These carry positive and negative signs. So the problem reduces to what is the coordinate of the point on the circle that intersects with the x-axis. All right. So let's see if we can, and this is very simple. We can use the geometry of the circle to find the coordinates of what I have labeled point 1 and point 2. Next slide shows that. There it is. There it is. In fact, the answer to this question here, if you look in the bottom here, it says 6.49 KSI. KSI, that's keps per square inch. 6.49 is the coordinate of this point 1 here. And minus, Mary, look, it carries a negative. Minus 10.49 KSI is the coordinate of point 2. Now, how I did it, it's very clear here. Please take a look and follow the solution that I have here for you. But I don't want to simplify things too much. I want to step through this with you. You see this R? What do you think R stands for? You got it. That's the radius of the circle. And the radius of the circle, this is one radius right there. Let me, gosh, this is not good. Let me see if I can erase that. And here it is. This is the radius of the circle. This is the radius of the circle, and this is the hypotenuse. And you see what I did? Square root of 6 squared plus 6 squared. The 1, 6 is here. You see that? This is a 90-degree triangle. And the other 6 is this, the distance between -2 and -8. That's 6 units. So does everybody see that? That's how I calculate the radius. And then I use the radius to come up with the coordinates of sigma 1 and the coordinate of sigma 2. Does everybody see that? Now, common mistake. A common mistake is to get confused and not recognize that there are 2 points of importance here. One is the coordinate of -2. That is the center of the circle. Write a note to yourself. That is the center of the circle. The other point that's important is this. This is the origin of the axis. You see that? That's the point 0, 0. And all these dimensions are measured from the origin of the axis, from the point 0, 0. But the center of the circle also is very important because that's where the radius is radiated from. I don't know if that's the proper word to use or not, but sounds good. So does everybody see that? All right, so there it is. Those are the principal stresses. There's one other thing they asked in this question, in this problem. They say, could you also give us the maximum shear stress? The maximum shear stress, remember, that's the y coordinate. So let me ask you something. What is, yeah, Joseph, I see your question. I will answer that before we stop. What is the point on the circle that gives you the highest y value? And Matthew already answered that question. The point on the circle that has the highest y value would be this point or this point. Do you agree? It's the highest point on the circle that has the largest, the most maximum, if that's correct to say, value of the y. And y is the shear stress. All right? So here it is, guys. Shear, what's the maximum shear stress? Well, find the y value of that point, the highest point. And remember this dotted line, what is that? You got it. That's the radius. That's the radius. So there it is. Radius is equal to the maximum shear stress. It's the square root of 79, and it comes out to be 8.49. 8.49. Mary, I don't follow what you're asking me. But let's go back to the comment Joseph made. Joseph says, why is the angle 2 theta? And this also, the answer I'm going to give you is the answer to Matthew's question also. By definition, the angle on the circle is twice as much as the actual angle on the stress cube or stress square. I will repeat that. The angle on the stress square is always half as much as the angle that's on the circle. That's just a function of how we created the circle. All right? So that's why you see 2 theta versus 1 theta. 1 theta is the angle on the state of stress. The corresponding angle on the circle would be twice as much. I hope that answers your question. And Helen, yes, the answer to your question is correct. Is yes. All right, guys. This is all that I wanted to cover. This problem 5, I did not intend. It was not my intentions to cover this because problem 5 is not something you should worry about for the breadth part of the exam. However, those of you who plan to take the structures exam in the afternoon, I recommend that you please review problem number 5. And you can see the solution is given to you, and if you have any difficulty with it, send me an email. But if you're taking the structures in the afternoon, definitely go over problem 5. Poisson's ratio here, we will see this in a next session when I talk about, it's one of the future sessions when I talk about construction materials. We'll talk about Poisson's ratio. General state of stress, again, if you're taking the structures in the afternoon, take a